Exponents look scary until you learn a few simple rules. I've written down the exponent rules here. We have the product rule, the quotient rule, exponent power rule, power of a product rule, and negative exponent rule. So first, what is an exponent? Let's go over that quickly. An exponent is repeated multiplication. 2 to the second is 2 times 2. And if we repeat, 2 to the third is 2 times 2 times 2. Simply repeated multiplication. So when you see the base to an exponent, the base is multiplied by the number in the exponent. The base is here. And the exponent is here. This is called your exponent. Okay. That's an introduction to what exponents are. Rule number 1 is the product rule, which can be expressed as A to the B multiplied by A to the C equals A plus B. Sorry, A to the B times A to the C equals A to the B plus C. Okay, let's work through an example or two of that. Of A to the B times A to the C is equal to the A to the B plus C. The key point here is that the exponent needs to be the same. So if we wrote 2 to the second times 2 to the third, that will equal 2 to the 2 plus 3, or 2 to the fifth. Okay? And again, 2 to the fifth is 2 times 2 times 2 times 2 times 2, which would be 2 times 2 is 4. So 4 times 2 is 8, times 2 is 16, times 2 one more time is 32. So 2 to the second times 2 to the third equals 2 times 2 to the second plus 3, which is 2 to the fifth, which equals 32. Okay, that's an example of the product rule. So if we had 3 to the third times 3 to the fourth, take a second and do that problem. Okay, that would be 3 to the seventh. That's 3 multiplied by 3 7 times. Okay, that is the product rule. Quick note, you see that it's A to the B times A to the C. What that A represents is that it has to be the same base. We can't do, say, 5 to the second times 2 to the third and expect this product rule to work in this example because they have different bases. Now, rule number 2, the quotient rule. This is used when we're dividing exponents, okay? Now, let me give you an example. Now, remember, the same rule applies. It has to be the same base. And you can see the quotient rule here. So let's think about an example. What is 5 to the fifth divided by, let's say, 5 to the second? Think about that one for a second. Try it out. Okay, 5 to the fifth divided by 5 to the second is 5 to the fifth power minus 2. Okay, so we're subtracting the denominator's exponent from the numerator's exponent. So when we see that, 5 minus 2 is 5 to the third, which, knowing that it's repeated multiplication, we know equals 125. Okay? Again, the same rule applies. It must be the same base. So if we did 3 to the third divided by 3 to the third, what would this equal? Okay, we can say that 3 minus 3, we end up with a 0th power, 3 to the 0th, which always equals 1. All right, that is the quotient rule. All right, let's work on the exponent power rule. Expressed generally, you can see it here, is a to the b to the cth power. Cth. Is that a word? Okay, when we see this, when we see an exponent raised to a power, we can re-express it as a, and then we multiply these exponents. Okay, when you have an exponent raised to an exponent, they multiply each other. So this is a to the bth power times c. And I don't care if b or c is grammatically correct. This is math. So to give you a numerical example, let's say we had 3 to the third raised to the third power. Actually, let's switch it up. Let's make it to the 5th power. Okay? Take a second. I just explained. You can see it generally. How does this work? Okay, what we'll do is multiply the overall exponent by the exponent in the brackets to get a final answer of 3 to the 15th power. All right, that is the exponent power rule. Now for the power of a product rule. This flips the product rule we worked with earlier and flips it around. So when we have a, or let's say we have b to the a power times, make that a c to the a power. Now what happens is we have the same exponent in different bases, but we can combine that in the following way. This would be equal to b c raised to the a power. Let me go ahead and put brackets around that, because we're going to multiply b times c first and then raise it to the a power. Now, let's do this with a numerical example. Let's say 3 to the third multiplied by, let's just say 5 to the third. Power of a product rule. Okay, we can say that, what does this equal? 15 to the a. I did 3 times 5 here, which is 15, which equals a. Or we could also express it as 3 times 5 to the a. All right, and when you think about it, this makes perfect logical sense. Because we could also say that this is equal to 3 times 3 times 3 as a group, and then 5 times 5 times 5. Two groups of that, and we know multiplication is a commutative property, so no matter how we organize this, it's going to be the same result. What we're going to introduce is the negative exponent rule, a very important rule. A to the negative b is equal to 1 over a to the b, or a to the negative exponent is equal to 1 over the base to the exponent. All right, so let's see what this looks like in practice. Let's say 3 to the negative 3. What does that equal? It equals 1 over 3 to the third. Now, as you know, that equals 1 over 27. 3 times 3 times 3 is 27. So when you see a negative exponent, what you have is base times exponent. You have the fraction 1 over the base times the exponent. Now there's one final rule that I didn't put here that I want to introduce you to. It's a simple one. It is the zero power rule. Zero power rule. This one can be tricky because it sort of flies in the face of what you've learned about zeros and multiplication. As a preliminary, when we raise something to the first power, what does that equal? It equals the base. So 3 to the first equals 3. Okay? Because there's 3 times nada. There's nothing there. It's just 3. When we raise something to the 0th power, I'll express this generally first. When we raise any a to the 0th power, it is going to equal 1. Okay? Anything raised to the 0th power. So 3 raised to the 0th, and let's see what that equals. 3 to the 0th equals 1. I know that. Okay? 100 to the 0th equals 1. All right? That's the zero power rule. Anything raised to 0 equals 1. All right, thank you for sticking with me this far. What I'm going to do now is I'm going to put up a list of problems. I want you to look at it, know what rule you need to apply it, and get your answer. I hope you did well with those. I'm going to work through these really quickly for you. Make sure you got your answers right. X to the second times x to the fifth is x to the 2 plus 5, which is x to the 7th. All right, we move on to y to the 7th divided by y to the 3rd. Now we're applying the quotient rule. That's y to the 7th minus y minus 3, which is y to the 4th. All right, here we have 2x to the 3rd power, which is equal to first. This is equivalent to x to the 1st. So 2x to the 1st is equivalent to 2x to 2x with a power of 1 times 3, which is just 2x to the 3rd. Okay? And we're going down to 5. All right, we have one more up here. X to the 3rd to the 2nd power. Okay? This is the same as, we can multiply these two numbers and we get x to the 6th power. All right. Thank you for joining me in this video. Leave a comment if you would like to see fractional exponents next. Sorry, I seen that you couldn't see the 5 to the negative 2th power. Just wanted to get that in there. It's 1 to the 5th to the 2nd, which is the same as 1 over 25.